This is Miss Black, and this is Open Campus, and we are doing college algebra, and we're in Module 14. Today we're doing Module 14C. So far we've covered how to graph a circle, which is a type of curve. What we're going to do today in Module 14C is see another type of curve that we're going to graph. Now this curve is directly related to a circle. So let's go to the class notes and talk about it. Okay. If you look at the notes, the directions say that today we're going to be talking about graphing an ellipse. An ellipse is a circle, elongated. It is taking a circle and stretching it either horizontally or vertically. So what I want you to notice is the parts of an ellipse up in your notes. Every ellipse, just like a circle, must have a center point to plot. And that point is in the center of the ellipse. So what we use for the circle, HK, to represent the center, we're also going to use for the ellipse. So we're going to use HK to represent the center of the ellipse. Now what happens is, because in the ellipse you do not move from the center the same direction all four ways, we're going to have two different directions to move. So on an ellipse from the center, you're going to move horizontally one distance and vertically another distance. And one is going to be longer than the other. So what happens is, if you're at the center of the ellipse and you move in a direction left or right, it's going to make an axis, a line. And from the center, if you move the distance up and down, it's going to make another axis. Now we can't call those line segments diameters like we did in the circle because they're not the same distance. So in the ellipse, we don't have diameters. What we have is what we call a major axis, the distance between the two endpoints of a circle, that's the longest, and the minor axis, which is the distance between two endpoints of the ellipse, that is the shortest. So if you look in my first ellipse, the major axis is going across and the minor axis is going up and down. In the second ellipse, the major axis is now going up or down and the minor axis is going across. So you cannot call the distance from one end of the ellipse to the other the diameter. You either have a major axis, the longer one, or the minor axis, the shorter one. The two endpoints that connect the major axis are called the vertices. So that's important. When you have the major axis, the longer distance, those points at the end are called the vertices. So that's the parts of the ellipse. Now, what we got to be able to do is be able to look at the equation I give you and know it's an ellipse. So let's go and look here at our second information. That's what you have to memorize. The equation of an ellipse in standard form should always be x minus h squared over a squared plus y minus k squared over b squared equals 1. What I want you to recognize is it looks almost like the equation of a circle. The equation of a circle was x minus h squared plus y minus k squared equaled r squared. So let's think about this. Why does it look, the equation of an ellipse, look like an equation of a circle? Well, they're related. Every ellipse and every circle has a center point. And if you remember from Module 14A and B, the center of the circle is represented by the h and the k. So in this equation, the center of the ellipse is also represented by h and k. Now, if you look, it's still x squared plus y squared because we're talking about two curves coming together. So just like the circle, the x squared and the y squared, the plus brought the curves together. The same thing with the ellipse. The x squared plus y squared is bringing the curves together. What's different in this equation is there are denominators now. They're fractions. There's going to be a distance for A and a distance for B. Because with an ellipse, you can't move a distance r, a radius, because you're not moving all the way around in the same direction. So an equation of ellipse is always going to equal 1, so we can see those two denominators of those fractions. And those two denominators are going to give us our distance. Now, it's very easy to remember who moves in what direction. The letter A is always going to be underneath the letter X. And if you think about the x-axis, it moves left or right. So distance A for an ellipse is always going to move left or right from the center. Distance B is always going to be under the variable y. And if you think about the y-axis moving up or down, distance B is going to move up or down. So listen, all the letters go in alphabetical order. X goes before Y. H goes before K. A goes before B. So if you remember that, X, H, and A should always be together. Y, K, and B should always be together. And A is always going to be under X, so that's why the A distance is going to move left and right. B is always going to be underneath Y. That's why the B distance is going to move up or down. So now what we're going to do is, how do we graph an ellipse? Well, to graph an ellipse is just like graphing a circle. You're first going to need your center, H and K, and you're going to plot that point. Then you're going to move not one distance, you're going to move two. So you're going to take your distance A and move left and right from the center. Then you're going to take your distance B and move up or down. So why don't we go to the whiteboard and try some examples with the ellipse. Okay, everybody, so what I want you first to understand is I'm going to give you an equation. I'm expecting you to look at the equation and know why it's an ellipse and not a circle and not a line. So I'm going to look at this equation. I see an x squared and a y squared. So I know it's not linear, so it can't be a line. I see x squared plus y squared. Well, that makes me think that's two curves. X squared's a curve, y squared's a curve. The plus brings them together. So now I have a decision. Is this an equation of a circle or is this an equation of an ellipse? The way you will know is by looking at the denominators of the fractions. If you look, there are two different numbers here in the denominator. That's telling you you're guaranteed to move two different distances from the center. And if you're going to move two different distances from the center, it's got to be an ellipse. If these denominators were the same number, if they were both 4s, or if they were both 25s, then you would be moving the same distance from the center, and that would be a circle. So it's really easy to tell it's an ellipse. It's still x squared, y squared, plus brings them together. If the denominators are different, you're going to move different distances, it's going to be an ellipse. So, to graph an ellipse, you need three pieces of information. You need your center. We discussed this. The center is always represented with the variables h and k. And those are always the numbers behind the x and the y that are either connected by add or subtract. So if you look, do you see anything behind the x? Neither do I. We can really rewrite this as x minus 0 squared. Do you see anything added or subtracted behind the y? No, you do not. This is really y minus 0 squared. So the same thing we talked about a circle is going to be true for an ellipse. If you do not see numbers added or subtracted behind the x and the y, we understand the center to be the origin, 0, 0. And we would plot that first. You have to start by plotting a point. So with the circle and the ellipse, we start by plotting the center. Now you need to move two distances because it's going to be an elongated circle. It's going to be an ellipse. Distance A is always underneath x. This stands for a squared. Remember when we did the circles, we had r squared. So to get the length of the radius, we did the opposite of squaring, which was square root. The same thing here. To get distance A, because this number stands for a squared, you're going to square root it. And it's going to be 2. And because we're talking about distance, it's got to be positive. So distance A is moving a distance of 2 from the center. Because A is always underneath x, and the x-axis always goes across from the center. We go 2 to the right, 2 to the left. All right, now we need distance B. Distance B is always going to be underneath y. It goes in alphabetical order. X, y, A, B. So this is B squared. So again, to get distance B, you're going to do the opposite of squaring. You're going to do square root. The square root of 25 is 5. Because it's distance, the answer's got to be positive. So from the center, we are going to move a distance of 5 up or down. Why do I know we're moving up and down? Because B is underneath Y. The Y-axis goes up or down. So we're going to count from the center, up 5, down 5. That's all we need to graph an ellipse. One center, 2 distances. Now, when you connect the points, do not make this look like a football where it would come to a point. That's not an ellipse. It's a curve. So when you make that curve, do half of it at a time. Start here, curve it, and come down. Come down and curve it. I know they're not going to be beautiful. It's a quick sketch. But do not make it come to a point. Then it's not an ellipse. Now, what I love about graphing is once you graph it, you could step back, admire your artwork, and answer some questions. And a lot of times the questions are in the picture. So let's look at our questions. Question D and E are asking the word length. Now remember, length is a distance. Now if you remember in our module previously, 13, we had a formula for distance. But we only have to use that formula if the 2 points connect and make a diagonal line segment. So let's look at our picture, look for our major axis, and see, do we need to use the distance formula or can we just use our picture? The major axis is the longest distance you would travel in your ellipse. So if you look, here's the center. The longest distance you're traveling is up here to down here. So if I connect that, this is your major axis. Okay, it goes from one end of the circle to the other. Because this is the major axis, these points are called the vertices. So we could say one vertex is at 0, 5. The other vertex is at 0, -5. Now I want the length of this. Do I need to use the distance formula? Very good. No. We could just count because it's going up or down. So how far is it to go from -5 to +5? Well, if you count as soon as you move your finger, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I started here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we would say the length of the major axis is 10 units. So we don't need to do the distance formula. Now I want the length of the minor axis. That would be the shorter distance you travel in the ellipse. And again, the shorter distance would go from -2 all the way to +2. So this is your minor axis. Again, do we really have to do the distance formula? No, we can count. So from -2 to +2, we're going to move 1, 2, 3, 4. Or if I count it this way, 1, 2, 3, 4. So the distance of the minor axis is 4 units. Everybody good? All right, our last two questions ask about the X-intercepts and the Y-intercepts. We discussed those words with lines. An X-intercept is where the graph would touch the X-axis. The Y-intercept is where the graph would touch the Y-axis. Now again, we already have the picture drawn. So can we look at our picture and see if our ellipse touches the X-axis? Well, if we look very closely, sure enough, touches the X-axis here and here. We have two X-intercepts. They are points. They need to be listed as points. The X value of this point is at -2, and this point doesn't go up or down, so its Y value is 0. The X value here is +2. Its Y value is 0. And it's the same concept with lines and circles. If you're sitting on the X-axis, your Y value's got to be 0. You're not moving up or down. Now, if you didn't want to look at the picture, how could you find the X-intercepts? Well, if you remember correctly, when we did Module 13 on lines, to find an X-intercept, you come to the equation and you replace Y with 0. So if you put a 0 up here, 0 over 25 would be 0. That would be gone. And then you would solve this equation. You would have x squared divided by 4 equals 1. Well, you know how to solve that. You multiply each side by 4. You would get x squared equals 4. Take the square root of 4. You get plus or minus 2. But why do the work if you have the picture drawn? All right, now we're going to find the y-intercepts. So if we look at our ellipse, does our ellipse touch the y-axis? It sure does, here and here. Now remember, those points are the endpoints of the major axis, so they are also called the vertices. But these are also, because they're on the y-axis, called the y-intercepts. So one y-intercept is at 0, 5, and the other y-intercept is at 0, -5. Again, if the picture wasn't drawn and you had to figure out the y-intercepts without the picture, you can go back and do what we did with the equation. We talked about this with lines in Module 13. To find a y-intercept, you let x be 0. So if you put in this equation as 0 here, 0 squared is 0, and 0 divided by 4 is 0. There's nothing there. So you would have to solve this equation. Y squared divided by 25 is 1. We know the opposite of dividing by 25 would be multiplying by 25. So we get y squared equals 25. We square root it, get plus or minus 5. So just so you all make the connection, everything that can be done by looking at the picture can be done by working the equation. But that's the major parts of an ellipse. How do you think? Not that bad, right? Let's try one more in our notes. So let me erase this equation and give you one a little bit more complicated. So let's erase these answers. Let's erase this pretty graph. And let's see a more complicated ellipse equation. All right, so let's see how you can do on this. So our next equation in our notes is, this is example 2, x minus 3 squared over 9 plus y plus 1 squared over 1 equals 1. All right, guys and gals. Now, the most important thing we're trying to get here is that you should be able to look at the equation and decide now, is it a line, circle, or ellipse? Okay, that's what we've learned to graph. Well, you have x squared, y squared. So you know because it squares, it's not linear, it can't be a line. That's out. So then the decision is circle, ellipse. Both the circle and the ellipse are two curves that come together. So that's why both equations have an x squared and they have a y squared. And the plus brings them together. Well, we have that. We have an x squared plus a y squared. So right now, we still got to decide circle or ellipse. What's going to be the deciding factor is the denominators of the fractions. If the denominators would be the same number, you'd be moving the same distance. That would be a circle. If the denominators are different numbers, then you're going to be moving two different distances. That's obviously going to be an ellipse. So if you look here, a squared is 9, b squared is 1. Because those are different distances, I'm guaranteed this is an ellipse. An equation of an ellipse in standard form has to equal 1. Now, once it's in standard form, all you got to do is get all your necessary parts to graph it. To graph an ellipse, you need the center, just like the circle, but you need two different distances, A and B. The center is H and K is always behind X and Y. And H is always behind X, because it goes in alphabetical order, and K is always behind Y. Now, we talked about this with the circle. What you see is not the correct numbers, because they were made the opposite, the additive inverse. The general standard formula for an equation of an ellipse and a circle are x minus h squared. That minus means whatever h was got to get changed. Equation of a circle and ellipse is y minus k squared. So whatever k was, that minus made it change. So we talked about this with circles. It's also true with ellipses. When you tell me h and k, you give me the opposite, the additive inverses. So your h value is going to be positive 3. Your k value is going to be negative 1. And that's what you would plot. 3, negative 1. Now we need our distances. A squared is not our distance. We need to square root that. So the square root of 9 is 3. A squared is always going to be under x squared. So if x axis moves left and right, your A distance moves left and right. So from the center, we're going to move 3 to the right, 1, 2, 3, and 3 to the left. Okay? Distance B is always underneath y. So the B is a 1. We're going to square root it because that's B squared. So we're going to square root it to get B. We're going to get 1. Again, because the key word here is distance, that's why these square roots are positive. So again, we're going to move a distance 1 from the center. So here's the center. We're going to move up 1. From the center, we're going to move down 1. Okay, so we move the distances from the center, just like we did with the circle when we moved the radius. Again, when you connect the points, it's got to be a curve. So watch me. I'm going to connect the first half. I'm going to connect the second half. Okay, I know it's not going to be beautiful. Just don't make it come to a point. That's your picture of your ellipse. Now we're going to step back and answer our questions. First question is length of major axis. Major means the longest. What's the longest distance we're traveling in this ellipse? Well, it's from here all the way to here. We don't need the distance formula. We can count. 1, 2, 3, 4, 5, 6. If I start here, 1, 2, 3, 4, 5, 6. So we would say the length of the major axis is 6 units. And you're right, it's double the bigger distance, 3. The length of the minor axis is the shortest distance we would travel. Up 1, down 1. So that's 1, 2. So we'd say the minor axis is 2 units. And you're right, it's doubling the shorter distance. Now the coordinates of the X-intercepts and the Y-intercepts. Don't assume with curves that means you're always going to have 2 X-intercepts and 2 Y-intercepts. The word intercept means to touch. An X-intercept is where you touch the x-axis. Well, if you look at our ellipse today, it only touches the x-axis in one point. That's right there. This point is the X-intercept. What is it on the x-axis at? 3. So our X-intercept is 3, 0. If you look at for your Y-intercept, how many places does that ellipse touch the y-axis? Not 2, only 1. This is your Y-intercept. That's where you're touching the y-axis. And that y value is -1. Its x value is always 0. So you got to be careful. X-intercept and Y-intercepts are very specific points. Where you touch the x-axis, where you touch the y-axis. Yes, sometimes an ellipse will touch the x-axis twice and the y-axis twice, but not always. All right? Just to reiterate one more vocabulary word. The 2 most important points on your ellipse are called the vertices. The vertices are where the major axis begins and ends. So if I asked you for the vertices, you would say, well, here's where the major axis begins, 0, -1. Here's where the major axis ends, that's 6, -1. So those 2 points are special. They're called the vertices. And that's all there is to it, guys and gals, how to graph an ellipse. It's related to a circle. That's why its equation should look like a circle. The only major difference is, with a circle you move 1 distance, the radius. The ellipse you move 2 distances, A and B. All right, in the next module we learn another curve. Thank you.